Tilia Phoenix is the industry's first artificially intelligent planning algorithm. Phoenix works by modeling your customers' production environment, their presses, their stocks, finishing equipment, and all the costs involved around manufacturing their products. This makes Phoenix's AI brain smart and ultimately derive the results that are the most cost effective. So I'm ready to share with you today two example use cases. The first one is from one of our customers who are evaluating ganging versus not ganging e-commerce mailers. So in this example, we pull in a set of the customer's orders. These orders have a number of line items here, each with a different ordered quantity. So box one has 40 boxes, 300, 100, 500, so on and so forth. Now, we import these into Phoenix, and Phoenix then gives us a thumbnail view of each one of these boxes. You can see that we can make pre-press type edits to these boxes, extracting the die information, changing the bleeds, adding production marks and things like that. But the workhorse behind Tilia Phoenix is our imposition AI algorithm. Now, this particular customer was running every single order on a press run by itself, doing no ganging. So when we replicate that process inside of Tilia Phoenix, we get a result that looks something like this. Now, in this scenario, Phoenix has replicated their exact workflow, taking one box and putting each box on a layout by itself. This results in a run length of 870 total sheets and about 40% waste. Now, using Phoenix's intelligent ganging algorithm, I can ask Phoenix to go ahead and look at the various stocks that each one of these products is going on, look at their various ordered quantities, and then more importantly, look at the cost associated with these different combinations and find more effective ways to produce these jobs. You'll notice here that after about 30 seconds or so, Phoenix has generated 72 different possible combinations, reducing the overall run length from 870 sheets down to 780 sheets, so almost 100 sheets better. And we reduced that waste from 40% down to 33% just by more efficient ganging. Now, of course, this type of workflow could really only be facilitated with digital cutting equipment like Highcon, which is what makes our partnership so valuable. We can take this whole process one step further and start to give better insight for our customers into how we finish different scenarios. So in this example here, rather than just looking at ganging for printing, I'm now going to look at ganging across different devices for different finishing processes. So in Phoenix, I've now modeled a Highcon Beam 2. I have included things like the cost per hour, the amount of setup time, as well as the speed of the Highcon Beam 2. I've also set up inside of Phoenix a traditional BOPS die cutter, a 106, with its hourly rate, its setup and make ready parameters, and its speed. We're also going to look at things like finishing on digital cutting tables like a Zund or a Kongsberg for applications that might be larger than neither of these two formats can handle. And we're also going to model things like die costs for conventional die cutting and dart costs for our Highcon cutting equipment. Once again, I've got another CSV. This is a slightly different job here. This is going to be a multi-part display, a couple SKUs. I pull this into Phoenix and I've got a red display, I've got an orange display, and I've got a blue display, all of varying quantities. Now, once again, I'm going to use Phoenix's imposition AI algorithm. I'm going to select all 13 of these products. This time I'm going to select multiple potential finishing devices that our customer could use to produce this job. I've got the Kongsberg C64, the BOPS 106, and the Beam 2. Now, this is where Phoenix gets really, really smart and really, really valuable for your customers, because now we have a cost-based approach to figuring out very quickly what makes the most sense to go to which devices. The results that we get look something like this. Phoenix is suggesting that we produce this job in 10 layouts. Layout number 10 is going to go to our Kongsberg, our C64, for 200 sheets. We're going to cut number 9 on our Kongsberg C64. Again, these are large parts, so they're just kind of automatically going to the Kongsberg table. But then around layout 7 here, we get our first suggestion that we should produce this layout on our beam, run it for 667 sheets, and we're going to be cutting on that beam for about an hour and 20 minutes. Another beam layout here. This one is gang, so we have 2 different parts on there. Once again, we're going to be on the beam for about an hour and 37 minutes, and this cost here includes the cost for our dart. And then finally, at the very end here, we get a couple layouts that are going to go to our our BOPS 106. These are a run length of 10,000, and my customer already has an existing steel rule die for this particular product. So Phoenix is saying it's going to be more cost effective to run this on our traditional die cutter. There you have it. We have 10 layouts here, all with the data, the run lengths, the time on press, and all of this information that our customers need to make really insightful decisions about how to best produce a job.